Hey friends, here we are in chapter 8, looking at section 8.6. We're going to talk about the law of sines and the law of cosines. So the cool thing about what we're going to discuss today is these law of sines and law of cosines, that's our vocabulary today, is that, since we've been talking about like our trig functions, we've been all about the right triangle, right? We've been all over it with two hands. Everything has been right triangle this, right triangle that. But now the law of sines and the law of cosines can be used on any triangle, for any in quotes triangle. Um, you can this is now an opportunity to use our trigonometric functions, relationships, identities, ratios to answer some other questions. So this should be a little bit more exciting, and you might find a little bit more practicality in this lesson. So let's go ahead and take a look. The law of sines and law of cosines being our vocabulary, I thought it was best just to show you what those laws are. And so the law of sines basically says, hey, walking down the street, you see any old triangle. Here's what you need to know. You need to know, first of all, let's just eyeball this. If this side is called angle C, the side opposite it is little c. And this is standard math practice. So I want you to feel comfortable saying the side across it is called C, the angle across that is capital C. And same with angle A, side A, angle B, and side B. With that in mind, here let's talk about the law of sines. The law of sines said if you got this walking down the street, you see this regular old triangle, and A, B, and C lowercase represents the lengths of the sides, and the opposite angles are A, B, and C, which we just talked about. Then check this out. The sine of angle A over A is going to be the same as the ratio of the sine of angle B over B, which is going to be the same as the sine of angle C over C, which seems a little bit like, okay, what? But it's going to help us solve some triangles like you wouldn't believe. So you're going to see some nice things happen as a result of that. And over here, the law of cosines is a little bit more involved. Like this one is kind of fun, the law of sines, because it's easy to memorize. And this one kind of, sorry about that, looks a little bit like a bootleg Pythagorean theorem. You see a squared plus b squared equals c squared and then some other stuff. And then you see it turned around where b squared is equal to a squared plus c squared and then some other stuff. So I want you to pay attention as we talk. Again, the orientation of the sides and the angles will be the same here, where angle A is across from side A, so forth and so on. Let's read. If triangle ABC has a length ABC, right, represented by the opposite sides with the measures A, B, and C, we already talked about it, this is going to be the case. So watch how we just have to memorize this. I'm going to, let me see if we can ignore some stuff, because sometimes, I don't know about you, sometimes seeing too much stuff at one time is frustrating to me. So I'm going to take off the back end of all of this just for a second. And I want to talk about just this first part. So if I needed to find out information about side A, I'm going to treat it like, and you remember a squared plus b squared equals c squared. In a way, I'm going to treat it like c squared. It's going to be the leader in a sense. So if I wanted to know about A, I would have to say, well, or side A, I'd have to say, well, a squared is equal to b squared plus c squared. But since we're not dealing with a right triangle, something else has to play. In fact, a squared can't equal b squared plus c squared. It's going to be a little bit less than, right? Because it's not the hypotenuse of the particular triangle, because we can use this when we're dealing with any kind of triangle, not just a right triangle. So now let's see, just focus on this one. Notice that it's now, the formula says minus, which makes sense, a little bit less than 2 times B and C. That's the two angles that are the two sides that we're not referring to. That's not the leader in a sense. So 2 times B and C times the cosine of angle A. Look at how A is here and A is here. B and C are stuck inside in a sense. And you'll see the same thing when I'm talking about side B. B squared is equal to A squared plus C squared, the other two sides, minus 2 times the other two sides times the cosine of B. Notice how the B's are on opposite sides there. I am doing this talk just to help us memorize it. I'm not doing it like this is earth-shattering information, but I want you to see the similarities between these equations so that you're not put in a place where you're like, oh my gosh, I got so much to memorize. So look, here's C and here's C. C squared is equal to A squared plus B squared. Looks like the Pythagorean theorem, but it's not because we're not dealing with a right triangle. We got to subtract some away. How much away? Minus 2 times A times B times the cosine of C. Notice that AB and AB are here, and we got the C's on the outside. Are you guys with me? All right, stay close. Let's go ahead and see if we can use these rules, these laws, to do some problems. So sometimes I love it when the textbook tells us exactly what to do. We don't even have to think about it. We're going to use law of sines. And so since we're now learning this concept, we're going to write sine of angle A over side A is equal to sine of angle B over side B, which is equal to sine of angle C over side C. In previous videos, guys, you know I've talked about if you've got ratios that are equivalent, you can just take the reciprocal of them. Keep in mind you can totally do that. So another way of writing the law of sines, you can write A over sine A. It's true, right? Is equal to little b over sine B. Once you keep everything where it's supposed to be, you're totally justified in writing it as a reciprocal. All right. I don't know if some mathematician somewhere would be like, this is heresy. It's not the law of sines. But the fact is, we're really just worried about the ratio. Sorry for my mathematician accent there. Let's go ahead and try to use this to solve the problem. So here we go. We need a pair. We need an opposite pair. I need sine A or a side A and a side A and an. This is. Do you hear the bells? They are so loud. They are irritating me. Hold on. Okay, the bells have stopped chiming. My goodness, they were so loud. Okay. Beautiful music, but yes, not when you're doing a video. I probably shouldn't be doing it by the window. Anyway, let's get back to the math. All right. So, we have angle C here and we're looking for side C. Let's keep that ratio in mind. We have angle A and we have side A. I'm pointing this out because you know how I say in previous videos, you got to use what you got to get what you want. What we've got is this nice ratio here. We've got sine A, we've got A, angle A, and we have side A. So that means we can use that. Like we can't do it for B, right? Because we don't know what angle B is. Well, I guess we do if we just do some subtraction, but you know what I'm trying to say. All right. So, but we don't have like the pair, right? The pair of angle and side, and that's what we need. So sine of 97 degrees over 16 is equal to, use what you got to get what you want. We want what's in green. Sine of angle C, which is 21 degrees, over X, which is the side, which is side C. So now all I need to do to solve for X is I've got to just plug this into my calculator and do my thing. But wait, you know how I like to have everything calculated ready. So I'm going to do our famous reciprocal trick where we take the reciprocal of both sides because it's easier for me to solve for a variable when it's in the numerator than when it's in the denominator. So I'm doing that, and then I'm going to multiply both sides by sine of 21. When I do that, right, when I multiply both sides by sine of 21, pardon me, sweeties, by sine of 21, I'm going to get a cancellation here, and then I'll get that X is equal to 16 times the sine of 21 degrees, all of that jazz over the sine of 97. And now this is calculator ready. So let's go to our calculator. So I've got Desmos here, handy dandy. I'm going to do 16 times the quantity of sine of 21. And I've already made sure that my calculator is in degrees and not radians. All right. That's a big mathematical issue because then you get all these calculations that's totally off. All right. So then we have that X is equal to 5.776. Let's say that X is equal to approximately 5.8. And now that we've got that, X is equal to 5.8. What I like to do, to be honest, is I'll ask myself, does it make sense? Does it make sense that across from 97 degrees, you've got this long side that's 16, and across from 21 degrees, you've got this small side that's 5.8? And we remember how triangles work. The larger the angle, the larger the side across, the smaller the angle, the smaller the side across. So to me, that feels right, and I feel confident about my answer. Here's another opportunity for us to use law of sines. By the way, I want to pay attention to if you have angle, side, right? Angle and angle and a side, you can use law of sines. Here's another opportunity. If you have angle, side, angle, you can use law of sines. So in this case, I'm going to write down our rule again. Okay, there's the law of sines. And now what I'm going to do is just highlight to help myself understand what I've got, okay? So they want us to find x. What is opposite side x? Angle 45. I've got angle 73 where this is opposite that, and then I have angle I don't know where 10 is opposite that. And so you remember, use what you got to get what you want. Here it looks like we have a whole lot of not knowing what's going on. But you remember I slipped up in the video last time. Well, slipped up isn't the case. I said, oh, we don't have this angle, but I was like, but wait, we do. We do have this angle. We have angle K, and we have it because we know that the interior angle sum of a triangle is 180. So we know that angle K plus angle 45 plus 73 is 180, and then we can calculate with a little bit of algebraic finesse that angle K, the measure of angle K, I should have that here, is equal to 62 degrees. So now that I have that the measure of angle K is equal to 62 degrees, I don't really need this information anymore. Now I'm going to apply the law of sines. Let me shrink that, get that over here. So how does the law of sines work for us here? Use what we got, which is 10 and 62, those two sides. So the sine of 62 degrees over 10 is equal to, use what we got to get what we want, sine of 45 degrees over x. And you know what? I'm going to do the same old, same old. I'm going to take the reciprocal of both sides, which just works out for me for solving for x, right? Take the reciprocal of both sides, and then after I do that, multiply both sides by the sine of 45. And then I have my problem and it's calculator ready. Yes, x is equal to 10 sine of 45 degrees over sine of 62. Let's go to our calculator friend here. And with a few pushes on the keys of my computer, I got the answer. The answer is 8.008, which we're just going to say is 8. So that's what we have for this one. Let me go ahead and write that down. X is approximately equal to 8. All right, did they give us anything to the nearest tenth? All right, if they want it to the nearest tenth, tenth is right there. Round that up. Nope, still 8. All right, so if they do nearest tenth, we should do like 8.0. Like we're sure that 0 should be in that spot. Cool beans, we feel okay? Let's go ahead and do our little check. If this is 62 degrees and I have 10 across it, across from 45 should be about 8. That may, or, you know, 8 makes sense to be there. So I'm feeling good. I'm feeling good. I'm feeling good. So with that, we have a few more examples, a lot more examples actually. And I think what I'll do is I'll let you deal with law of sines and absorb that, and then we'll look at law of cosines. It's a little bit more involved, but I know we're going to have to do at least 2 or 3 videos for this. So let's stop here. I'll talk to you soon. Let me know if there's any questions about law of sines, and I look forward to talking to you soon about law of cosines.